Now I want to talk about vector product or cross product. So before we can do it, we want to give a notation of a 2 by 2 determinant. So say this is called a 2 by 2 determinant. You have A, B, C, D with two lines on the left and the right. So this is defined as AD minus BC. So that is, you first multiply the elements of the diagonal and then do the subtraction. So say you're given two vectors, a1i vector plus a2j vector plus a3k vector, and another vector is b vector, which is b1i vector plus b2j vector plus b3k vector. So we need to find the cross product of these two vectors. So cross product of two vectors is nothing but a 3 by 3 determinant. So the first row is I vector, j vector and k vector. So since this is A cross B, we first write vector A, A1, A2, A3, then vector B, B1, B2, B3. So this is equal to I vector times 2 by 2 determinant A2, B2, A3, B3. Now this could be difficult to remember. So a small trick to remember this is, you just delete the elements under the I vector and the remaining elements you take a determinant of. So remaining are A2, B2 and A3, B3, you take their determinant. Now minus j vector, notice there is a minus sign here, times A1, B1, A3, B3. So 2 by 2 determinant of this. Again, to remember it, you just delete the elements under j vector and the remaining elements you take the determinant of. Plus k vector now you have A1, B1, A2, B2. Again, you just delete the elements under the k vector column. And that is how you get A cross B. Now this will be more clear in an example. So let us take A vector as A vector this is given as I vector plus 2j vector plus 3k vector, and you have B vector which is given as 2i vector plus j vector. So A vector cross B vector, you have I vector, j vector and k vector, 1, 2, 3, 2, 1, 0. So I vector, so you write 2, 1, 3, 0. So you remember that you delete the elements under the I vector column and take the other two elements remaining there. Then minus j vector, you have 1, 2, 3, 0. Again you delete these two, you have 1, 2 and 3, 0 remaining, plus k vector times 2 by 2 determinant of 1, 2, 2, 1. So again, to remember it, you delete the elements under the k vector. So this gives you I vector times 2 times 0 minus 3 times 1. So this is the formula AD minus BC. So you have 2 times 0 minus 3 times 1 minus j vector 1 times 0 minus 2 times 3 plus k vector 1 times 1 minus 2 times 2, which is 4. So 1 minus 4 is minus 3. This will give you minus 6. And this will give you minus 3. So our answer would be minus 3i vector plus 6j vector. So minus 6 times minus j is plus 6j minus 3k vector. So this is the A cross B. Now, a very important remark is that this vector A cross B is perpendicular to both A and B. So we write this down. So A vector cross B vector is perpendicular to both A and B. So what we are writing is that A cross B vector gives you a new vector. Now this new vector is perpendicular to both A and it is perpendicular to B. So let A vector cross B vector be some vector you denote by C. Then C vector dot product with A vector would be length of C vector times length of A vector times cos theta. Theta is pi by 2 here because they are perpendicular, so this is 0. Similarly, C vector dot product with B vector would be 0. So let us do an example. We have already computed A vector cross B vector. So we now just take the dot products. So you are given A, B and A cross B. So A vector cross B vector dot product with say A vector. So this is equal to minus 3, 6, minus 3 for A vector cross B vector, and A vector is just 1, 2, 3. Now you do the multiplication coordinate wise. Minus 3 times 1 plus 6 times 2 plus minus 3 times 3. So you get minus 3 plus 12 minus 9, which is 0. So again, similarly you can compute A vector cross B vector dot product with B vector. So this is minus 3, 6, minus 3 dot 2, 1 and 0. So minus 3 times 2 plus 6 times 1 plus minus 3 times 0, and you again get 0. So you can see A vector cross B vector dot product with A and B is 0.